All right, continuing with factoring polynomials. A little bit different situation this time. We still have a quadratic. We still have an x squared. We still have a trinomial. We still have three terms that we're dealing with here. But this time, we have an a right here. We've got a number in front of the x squared. So in this case, we're dealing with what happens when there's an a involved. And a lot of it's the same. There's a few extra steps at the end, but the bulk of the process is the same. We just do a couple little tricks at the end to fix this a being there. All right. So step one, actually before step one, I kind of have these little asterisks here because before you do anything else on these trinomials, now that we have something in front of x squared, the first thing I need you to do is check for a greatest common factor. Okay, always check first. Because if there is a greatest common factor in all of your terms, pull it out. Because it's going to make the problem a lot simpler. Let's rephrase that a little bit. Pull it out. It's going to make factoring a lot simpler. And when you do pull it out, you're going to actually just pull it to the bottom, and you're going to completely ignore it until the very end. So just for example, if I had 6x squared plus 9x plus 12, there is a greatest common factor in 6, 9, and 12. It's 3. So I'm going to pull it out and end up with 2x squared plus 3x plus 4. But this 3, I'm going to ignore until the very end of the problem. And I'm going to put it in front of my final parentheses. Otherwise, I'm just going to pretend like it was never there. Okay. So if there is a greatest common factor, and it doesn't happen very often, we'll do one example today where it does happen, and you can kind of see the process. But if there is one of those, get rid of it, okay? So step one, the first thing that we're going to do is we've got to deal with this a. We don't like it being there. So we kind of have to steal the a from the front and move it to the c at the back. So we're going to say that step one is to kidnap a. Okay, we're going to kidnap a, and what we're going to do is we're going to multiply it at the back. And this is totally breaking so many mathematical rules, but we're going to do it anyway. So down here at the bottom, our example, 7x squared plus 29x plus 4. I'm going to take this 7, I'm going to kidnap it, and I'm going to multiply it at the back. So my new problem is x squared plus 29x, and instead of a 4, I've got plus 28. And I'll repeat, we're breaking rules right now. We're kind of just making stuff up to simplify the factoring, and then we'll fix it later. But for now, let's go with it. So now that we've gotten rid of the a, we can just factor like we did before. We can just factor as if a is equal to 1. We're going to pretend like we didn't do anything at all. So I'm going to take this 28, and I'm going to put it up on top. So this 28 is going to go right here. But remember that that's not just c anymore. Now that's a times c on top. We're still going to look for things that multiply to be 28. And the 29 is going to go on the bottom. Okay. And we're looking for things that add up to 29 and multiply to be 28. So on the bottom, we still have b, but on the top, we've got that a times c. So again, we kind of started with an easy one. It multiplies to be a positive 28, adds up to a positive, so they're both positive. And they're going to add up to 29, so we've just got 28 and 1. All right. So once you finish factoring, once you finish that process, you're going to fill out the parentheses just like you would if that a wasn't there. We're going to fill out the parentheses. We're going to pretend like we haven't done anything. So down here, I'm going to put x plus 28, and I'm going to put x plus 1. Now, here's where we broke some rules. So we kind of got to fix it. We can't just say, oh, I'm done. I'm finished. Let's move on, because we kind of broke some rules to begin with, and now we've got to fix it. We kidnapped that a, and so we've got to make up for that. So what? I don't know. We can say, let's go searching for a. We kidnapped A, or someone kidnapped A. Let's go searching for it. And what you're going to do is you're going to divide your factors that you found. You're going to divide those factors by A. And then you're going to simplify. You're going to divide and you're going to simplify. So what I mean is we kidnapped A. Now that we're looking for it, let's put it back, kind of. We're going to put it back right here underneath our factors. Because we multiplied by A, now we're going to kind of divide that away. But I need to simplify because 28 over 7 simplifies and I get x plus 4. On this side, 1 over 7 doesn't simplify. That just stays 1 over 7. All right. Now we're almost done. So we went searching for A. We ended up with a plus 4. We ended up with a 1/7. And we're pretty much done, except for we've got to rewrite this. So we're going to return any denominators that are left. If there is anything left in the denominator, you're going to return those to x. Well, I guess we better say specifically, we're going to return those denominators to their x. And I know this just sounds like a whole load of garbage right now. We're going to do a few examples and you're going to have it figured out, okay? So this denominator right here, I'm going to return it to the x. So I'm going to end up with x plus 4. And instead of this 7 down here, I'm going to return it up to the x, 7x plus 1. Now I have my answers, x plus 4. And that 7 that I kidnapped is returned. It's back in here in front of the x, okay? Now, I would always, I think it's probably a good idea, especially as you're learning this process, I would check your work. Check your work. Make sure that when you FOIL this out, you get the problem that you started with. I'm not going to take the time to do that right now. I don't want this video to go longer than it needs to, but pause the video, multiply that together if you want to check, and make sure we got the right answer, okay? All right, let's do some examples. I know, again, that we just made up a whole bunch of stuff. I mean, we do that as mathematicians sometimes. If something doesn't work, well, let's break a rule, see if we can make it work, and then we'll fix it when we're done. So our first example, let's start with something kind of simple. Let's do 3x squared, and we'll add 8x, which means we need a minus 3. All right, so first of all, I have an A up here. I need to kidnap it and bring it here to the back. So my new equation is x squared plus 8x, and this 3 gets multiplied by the negative 3 to become negative 9. And now I can just factor. Negative 9 goes up here. The 8 goes on the bottom like it always does. Now this time I'm looking for two numbers that multiply to be a negative. So they need to multiply up here, which means one's going to be a negative, one's going to be a positive. But they're going to add up to a positive, which means my biggest number is going to be the positive. And again, the factors for this one, they're pretty easy. It's just 9 and negative 1, because 9 and negative 1 add up to 8, and they multiply to be negative 9. So we put them in the parentheses, as if we didn't break a bunch of rules earlier. I'm going to put x minus 1 and x plus 9, okay? Now, we got to go looking for that A that got kidnapped. So I'm going to divide this negative 1 by the A, by 3, and I'm going to divide this 9 by 3. And then I'm going to simplify. X minus 1/3, that doesn't get any simpler. But x plus 9 over 3, that's just x plus 3. So I'm going to change that to x plus 3. And my last step, I've got this denominator down here. That's not where it belongs. I need to return it up here to its x. So I get 3x minus 1 and x plus 3. So 3x minus 1 and x plus 3. I think those are the right answer. You can FOIL, double check, and see if we did the problem correct. All right, example number 2. Let's scroll down just a little bit. And let's do something just a little bit more complicated. Let's say 12x squared minus 5x minus 2. Not a lot more complicated, but we still have an a that we got to kidnap and get rid of. So we're going to move it there to the back. So we've got x squared minus 5x. 12 times negative 2 is negative 24. So when I set up my x, my big X, my negative 24 goes on top, my c value, my new pretend c, and my negative 5 goes on the bottom. So they're going to multiply to be a negative, which means one's negative, one's positive. But this time when I add them together, I get a negative 5. So that means my bigger number is going to be the negative. So factors of 24, we've got 6 and 4. Those don't add up to 5. We've got 12 and 2. They don't add up to 5. But we also have 8 and 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So let's put those in parentheses. X minus 8 and x plus 3. Okay, now I've got to unbreak all those rules that I broke. I stole this 8, we kidnapped it, or this 8. We kidnapped this a value, the 12. So we got to go searching for it. Let's try putting it back in right here. So x minus 8 over 12, that becomes x minus, if I simplify that, that's 2/3. And this one, x plus 3 over 12, that simplifies to 1/4. If you're not very good at simplifying fractions, plug 8 over 12 into the calculator. In fact, let's show you really quick. If I do 8 divided by 12 and hit enter, it's going to give me a decimal. But if from there, if I go math, enter, enter, it turns it into a fraction, but it's in simplest form, and it tells me 2/3. So go ahead, use that trick if you need to. Now this time, when I return my denominators, they both have denominators. So this 3 is going to get returned to the x, and this 4 is going to get returned to the x. So I get 3x minus 2, and I get 4x plus 1. Now, if you FOIL, you'll end up with the same thing we started with, 12x squared minus 5x minus 2. So you can pause the video and check that if you need to. This one was a little bit different. The last time, we just had one fraction that we had to move up. This time we had 2. Sometimes it'll be 1, sometimes it'll be both. It's all going to depend on what the numbers are that you're dealing with. Okay, so let's do one more. Our third example, let's change colors here so that we don't get mixed up with other stuff. Let's go with 25x squared because we haven't done one of these yet. And then let's say minus 45x, and let's take away 10. Now, I told you step 1 is to look for a greatest common factor. We kind of skipped over that up here because we didn't have any. Here, they were all way different. But this one, we actually have a greatest common factor in 25, 45, and negative 10, and it's 5. So I'm going to factor that out. 25 divided by 5 is 5, and I'm left with x squared. Negative 45 divided by 5 is negative 9, and I'm left with the x. Negative 10 divided by 5 is, negative 2. So I pulled out the greatest common factor. Now, instead of having to multiply 25 and negative 10, this 5, I can just drop it clear down to the very end of the problem. And I'm just going to ignore it for a little while. And all I'm going to deal with is this part right here. So I've got 5x squared minus 9x minus 2. I've got a number in front of the x squared still that I'm going to kidnap and move it to the back. So I'm going to rewrite this up here. X squared minus 9x, and negative 2 times 5 is negative 10. So when I do my x, my big X, the negative 10 goes right there on top. The negative 9 goes on the bottom. And I'm just looking for two things that multiply to negative 10 and add up to negative 9. One's going to be positive, one's going to be negative because they multiply to be a negative. But we know the bigger number is going to be the negative because when I add them together, I'm going to get negative 9. So if I multiply 10 and negative 1, I get negative 10. But if I add those, nope, I did that backwards, guys. I said the bigger number was the negative. So negative 10 times 1 is negative 10. Negative 10 plus 1 gives me my negative 9. So I'm going to go ahead and put those back in my parentheses. X plus 1. So there's one of mine. The other one is x minus 10. Now here's where I've got to fix. I stole the 5. Remember, we kidnapped the 5, so we got to go looking for it. So I'm going to put it back down here on the bottom. Since I multiplied to steal it, I'm going to divide to put it back. And then I'm going to simplify. This one right here, x plus 1 over 5, just stays x plus 1 over 5. This one becomes x minus 10 over 5, but 10 over 5 is 2. So that becomes x minus 2. And now I'm almost done, other than that I've got this 5 on the bottom. I don't like that 5 on the bottom. I've got to return it up here to the x. So I end up with 5x plus 1 and x minus 2. And don't forget that 5 at the very, very front that we factored out to begin with. All right. So like I had mentioned in the last video, the goal here is give you one method that works most of the time. I want to try that this year. I want us to practice this X method a whole bunch, see if we can get good at it. I know it sounded like a little bit of gibberish, right? We kidnapped numbers and then we went looking for them and returned them. And we kind of moved numbers around and broke a whole bunch of rules. But at the end of the day, it got us the answer that we want. So we're going to go ahead and just pretend like we didn't break any rules. I'm okay with that.